Good job last night.
Thank you.
Okay.
You went?
What?
The heights of 9 volleyball players are listed below in inches.
I
So
just heard.
now, one thing that's key is you got to put them in order. Okay, so if you're given the heights of 9 volleyball players, you have to list them from smallest to largest first. 64, 66, 67 and a half, etc. Find the percentile rank of the girl who's 68 inches. So we want to know what the percentile rank of that person is. Okay. So the way you calculate that is with a formula. First of all, do you think she's above or below the 50th percentile?
Below.
She's in the bottom half, so she's going to be below the 50th. She's going to be somewhere below the 50th percentile. The formula that's used for percentile rank, or sometimes it's just called percentile, is you take the number of values below 68, below that number. So how many values do you see that are below that? 3. 3. 1, 2, 3. There's 3 values below that number, below x, so 3. You add 0.5, and you divide by the total number of values, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This formula is coming off your formula sheet, bottom left-hand corner, your formula sheet. Then you multiply by 100%. So I need a little help with the calculators.
38.9.
So you can have 3.5 divided by 9 times 100, 38 point what again?
9.
38.9. So that's the percentile. So about the 39th percentile approximately. It's the percentile rank. It's similar to what you get when you get your ITED scores back. You can go grab it, yeah. That's fine. Okay, B. Which height in the list corresponds closest to the 90th percentile? So maybe none of them are exactly at the 90th percentile, but if you had to pick one, which one is closest to the 90th percentile? If you had to guess, which number might you guess? Say it again. She's going to guess 70. That's a good guess. 90th percentile has to be one that's above 90% of them, so 70 might be a good guess. Let's see. Now the formula for this, it's on the bottom right-hand side of your formula sheet. It says C equals N times P divided by 100. Now, it doesn't really explain what all these values mean. So let's look in your textbook. Go ahead and get your textbooks out, because this is explained a lot better in the book than it is on your formula sheet. It's on page 140. And in the blue box, so there's a blue procedure table. There's a nice example above it on page 140. Just finding a data value corresponding to a given percentile. Number 1, arrange the data in order from lowest to highest. We did that. Substitute into the formula. N is the total number of values. P is the percentile. So we're going to try to find our C value here. So what number would I plug in for N? 9. That's the total number of values is 9. We're trying to get the 90th percentile, so you plug in 90 in there and divide by 100. 9 times 90 is 810. Divided by 100, which is 8.1. Now, step 3A in the book. If C is not a whole number, round up to the next whole number. Starting at the lowest value, count over to the number that corresponds to the rounded up value. So it says round up. So if we round this up, what are we going to get? 9. Yep. So that means go to the 9th value. 1, 2, 3, 4, 5, 6, 7, 8, 9. 72 is actually 72 corresponds closest to the 90th percentile. This gives you the 9th value. So that might not, and I would have guessed, when you guessed 70, Lauren, I would have guessed you were right. And it's close. If this would have came out at like 7.9, and we would have rounded up to 8, then we would have taken the 8th value, which would have been 70. So it was pretty close. None of the values probably match perfectly with the 90th percentile, but that one's the one that's closest. Now, what if this would have came out to exactly 8? let's say that C comes out to 8. So I'm just going to put what if C equals 8, because then it says something different. Step 3b, if C is a whole number, like 8, use the value halfway between the C and C plus first data values when counting up from the lowest value. So if C doesn't come out to 8.1, it comes out to exactly 8, then what's that mean to do? Go between the C and C plus first values. Where would I look? If C was 8, I'd look between which two values?
Between the two 70s?
Between the 8th and the 9th, yep. So if C comes out to 8, then you're supposed to go between C and C plus 1, which would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, it'd be, you pick the number that's halfway between the 8th and 9th one, which would be what? 71. So that's kind of tricky. But if C doesn't come up to a whole number, you round it up, and you just count over to that value. If C does come out to a whole number, then you go to that number and the one after it, and then you take the average of those two, so it'd be 71. All right. One of those little details that I didn't want you to miss in the book there. Okay, next. Find the interquartile range for the data set. Interquartile range, we abbreviate IQR, is third quartile, Q sub 3, minus the first quartile, Q sub 1. So the way we do that is we go to the data set, we have them in order already from lowest to largest. We find the middle number. There's 9 numbers. There's going to be one middle number. Which one would it be? 68. Right, 68.5, because we have 4 smaller numbers over here, 4 larger numbers up here. That's your median, or sometimes we call that Q sub 2, second quartile. We look at the bottom half of our numbers, which are these 4 numbers. Q sub 1 is going to be the number that's halfway between the halfway point of these numbers. So Q sub 1 is going to be right here. So if I want to figure out what's halfway between those, how can I do that? Add and divide by 2. So something between 66 and 67.5. If you add those together and divide by 2, anybody know what you get? 66.75. Good. That's your first quartile in Q sub 1. Q sub 3 is going to be a lot easier to figure. It would be the number halfway between 70 and 70, which would be 70.
So if you have like something spread out, like say it was 60 and 67, you'd still just find the range?
You find the average. Yep. Okay. So the interquartile range then is going to be, we need to come up with a calculator here maybe. Q3, which is 70, minus 66.75. So that's going to be 3.25. Any questions about that? All right, checking for outliers. We went over this yesterday. Now I want to give you a little bit of the logic behind it and explain it a little bit better. Yesterday I just said this is how you do it. Now let me try to give you some logic. Got a number line. The middle of our number line, our Q2, is in here at 68.5. Let me maybe just number this a little bit here. Let's say that's 68, 69, 70, 71, 72. Who's playing guitar? Any guitar players in here? We can see if we could play them. I can't play guitar. Okay, Q2 is at 68.5. So Q2 is about right there. Q1 is at 66.75, about right there. Q3 is at 70, about right there. What's the distance between those two? Between the Q1 and the Q3? It's not too bad. I'm not close to the door anyway. I'm distracted. You guys are up there. It's not an actual person. It's a YouTube video. Okay, so we already calculated this distance. What is it? 3.25. 3.25. That's the interquartile range. It finds the distance on the number line. It's the distance between Q3 and Q1, 3.25. Now, somebody out there said, well, how do we know if something's an outlier or not? Here's what they do. They're saying, well, if you take that distance and multiply it by 1.5, and somebody came up with 1.5, it's an arbitrary value, I'm not sure, why exactly it's 1.5, but they said if we take that distance and we plus another half, so times it by 1.5, so let's take 3.25 times 1.5, 4.875. So let's go that distance further to the right. So let's go 4.875 further to the right. And I don't have this drawn to scale necessarily, it'd be out here a ways. So in other words, take 70 plus 4.875. So that puts you out here at 74.875. And then do the same thing, go in the other direction. Let's go from, what was our Q1? 66.75. Let's go that way, 4.875. So subtract 4.875. 61 point something, 9, or what's that come up to? 66.75 minus 4.875. 61.875. Okay. So that's out here somewhere. So in other words, we went 4.875 this direction. And we got it ended up out here. 61.875. So you've got this distance here is our interquartile range. Times it by 1.5 gives you this distance and this distance. And then they're saying these are kind of our boundaries. Anything that falls between those two numbers is not an outlier. Anything that falls beyond 74.875 or before 61.875 would be outliers. So, do we have any numbers that are lower than 61.875?
No.
No. Do we have any volleyball heights that are above 74.875?
No.
No. So this one, there's no outliers. That's how you check for outliers. Again, you find your Q1 and your Q3, subtract to get your interquartile range, multiply by 1.5 because that's the method somebody came up with. Okay, it's always 1.5. Then add that value on to Q3, subtract that value from Q1. If your values fall in between there, if all of them fall in between there, that means there's no outliers. Any questions about that? So that's about 4 different concepts that I reviewed.